In this video, we are going to be writing a biconditional statement as a conditional statement, and then its converse, and then we're going to determine the truth values, determine whether or not it's true or false. Okay, so we have a biconditional statement which has the form P if and only if Q. Okay, so P is true if and only if Q is true. Okay, so this is equivalent to the following: the statement if P, then Q, and the converse of that is if P or if Q, then P. So you switch the order. Okay, so looking at this, we've got this table here. This colors green, red, white, purple, yellow, 2, 4, 3, 5, 4. Okay, and it gives us a biconditional statement. It says a light bulb costs $4 if and only if the light bulb was red. Okay, so it costs $4 if and only if the light bulb was red. So we want to make a conditional statement on that. Okay, so we go up here and look, and it says, based on this, this is your conditional statement. If P, then Q. Okay, so this right here is P, and then the light bulb was red is Q. Okay, so if we write if Q, then P, it will be if a light bulb costs $4, then the light bulb was red. Okay, so that is the conditional statement. If a light bulb costs $4, then the light bulb was red. That's based on this biconditional statement. A light bulb costs $4 if and only if the light bulb was red. So we wrote a conditional statement. If P, then Q. If this is true, then this is true. Okay, and now the converse of that is if Q, then P. So we will switch the order of this. So if Q, if the light bulb was red, if the light bulb was red, then what do you think? Well, the light bulb costs $4. Okay, so that's your two sentences. We have the conditional statement and the converse. Okay, so conditional statement is if P, then Q. The converse is if Q, then P. Okay, now we need to look and see about these three statements. Are they true based on the information that we have on the table? So first, is the biconditional statement true or false? Here's the biconditional statement. A light bulb costs $4 if and only if the light bulb was red. Okay, so we're looking for, is there another kind of light bulb that costs $4? Because it said a light bulb costs $4 if and only if the light bulb was red. We can see that the light bulb red costs $4. We also see that yellow costs $4. So that kind of says this statement is wrong. A light bulb costs $4 if and only if the light bulb was red is not true. It could also be yellow. So we're going to say false on that one. Okay. The conditional statement, if a light bulb costs $4, then the light bulb was red. Okay. Well, we can look here and see, yes, this is red. Nope, this is not red. So again, that is false. Okay, now let's look at the converse. If the light bulb was red, then the light bulb costs $4. So we go to red, we look at the price, that's true. The light bulb was red, then it costs $4. So that statement, the converse, is true. Okay, let's take a look at another one. Okay, again, we've got this information. Biconditional statement has the if and only if in it. So P is true if and only if Q is true. And it's equivalent to this statement, if P, then Q. And the converse of that would be if Q, then P. So just like the last problem we did. Okay, this time we have shapes over here and colors over here. Okay, so the biconditional statement that we're given is a toy block is a square if and only if the toy block is red. Okay, so the toy block is square if and only if the toy block is red. So this is toy block is square is if P if and only if Q. P is a toy block is square, Q is the toy block is red. Okay, so the conditional statement says if P, then Q. If P, then Q. If a toy block is square, then the toy block is red. Okay, if P, then Q. Okay, and the converse is if Q, then P. If a toy block is red, then the toy block is a square. Okay, so if Q, then P. That's the converse. Okay, so now again, we need to answer these questions. The biconditional statement, true or false, based on this information. A toy block is square if and only if that toy block is red. So is there any other toy block that's square that's not red? Okay, well, looks like we only have one square on this list, and it is red. So a toy block is square if and only if the toy block is red. That is a true statement based on the data that we have. There's only one square, and it's red, so true. If a toy block is square, then the toy block is red. That's also true. Okay, and then the converse, if a toy block is red, then the toy block is a square. So we can find the red. There's only one red, and what is it? It's a square. So if it's red, it has to be a square. That one is also true.